Okay, welcome again. Samuel Abizana, tutor, taking you through this area of mathematics. We are looking at this case of a force acting up along the line of greatest slope. And we want to say at this moment, because we said when the body is on a plane in this manner, there are two forces which we have via the the plane is smooth, so that is the weight, number one. And then you have the normal reaction R. So I still emphasize that candidate should remember that along here you have the vertical and along here you have the horizontal, such that the angle between the weight and the vertical is equivalent to theta. Okay. Now these are the two forces we have. Okay. So if we are saying that there's a force acting along the line of greatest slope, and this force is acting down, it's acting down, then you can always indicate the force down. The force is down. So please use a ruler when you're doing that. That is F. And so for starters, we have always said that you can produce this. You can always produce that so that you have the vertical and then you have the horizontal. All right, so we can see that on the vertical, we have our reaction R. Of course, along the horizontal, you have a force F in that direction. And down here, we have the weight mg acting at an angle of theta degrees to the vertical. And I say that now at this step, the student has to go ahead and look at the resultant force. Yes, obtain what we call the resultant force F. And so the resultant force, you can start with R. It's purely vertical, so this is 0, R. Then we have this, you can take it as F, as negative F because of that direction. Then 0 and plus, come to this, it's minus mg sine theta minus mg cos theta. Now, if the body is in equilibrium, we shall equate to 0, 0. So please don't forget that this happens if the body is in equilibrium. That's when you equate to 0, 0. But what if the body was not in equilibrium? What if the body was accelerating upwards? And it can't happen in this case when we put a force and it accelerates upwards. So this force has to accelerate downwards. So if it accelerates downwards, one thing I want students to always remember is that now when you're resolving, forces in the direction of acceleration are going to be positive. You will now consider the acceleration. Okay. So in that case, your resultant, if we have an acceleration, for reaction, it's vertical. So this is just 0R. And now when you come to the force F, you look at the acceleration. Now they're in the same direction. So this one is going to be a positive. Okay. Plus, now even the component of weight here will be the same direction as acceleration. That will be mg positive. Mg sine theta. And vertical is still a minus cos theta. So we come and equate these two. Ma0. Okay. Yeah. So if you had a force here, I'm saying if you had a force here P, then that you would add a force P, but now it would be negative minus P0. Reason, it's in opposite direction with the acceleration. Okay, let's look at some examples about this. All right, so yeah, we want to look at this example very, very fast. Our example, definitely we are saying that when you look at this question, there are a few pointers. There are some things the student should look for as you attempt. So you are given the mass, it's an inclined plane, the angle is 30. And then we are talking about a force which is acting down along the line of greatest slope. So very, very fast in your solution, you can come and look at this plane. Now you know the plane is inclined at an angle of 30 degrees. And then we have the body on the plane. So that's our body. Now we say there's two forces which act on the body. By the way, this act works if the plane is smooth. Hmm? When you're learning about friction, we shall see what happens when the plane is rough. So if the plane is smooth, then we have our weight mg. Actually, now our mass is 5. So you can see this is 5g. Then we also have our normal reaction r. And I have emphasized that we have the vertical here and we have a horizontal run here.